Hello again, class. This is Sir Kenny, your lecturer for today. Welcome back to STM005 or General Chemistry 1. For our meeting today, we will discuss module number 7, which talks about writing atomic symbol and ionic notation. But before we begin, let us go through our lesson objectives. By the end of this lesson, you can say that yes, I can find the numbers of subatomic particles in a given atom, and yes, I can determine the charge of an ion based on the numbers of subatomic particles. We have already discussed in Module 1 that matter is anything that occupies space and has mass. Now, these matter in turn are made up of atoms, and that these atoms are the basic building blocks of matter, and they cannot be chemically subdivided by ordinary means. So that means yung composition ng atom, hindi basta-basta yan na paghihiwalay by simple means. The most common way in which the atoms can be divided further into its smaller, more basic parts is through nuclear reaction. Now, medyo hindi na siya kasama sa atin because we are only going to discuss chemical reactions in chemistry. So what's an atom made of? Even though the atom is already really small, it is made up of even smaller particles. So gaano nga ba kaliit ang mga atoms? We have the ruler here to scale. Now dito sa ruler na to, meron tayong inches and we also have the centimeters. The distance between the two numbers, number 3 and number 4, for example, is equal to 1 centimeter. Now, in 1 centimeter, there are 10 millimeters. So if we are going to divide 1 centimeter by 10, saka natin makukuha yung millimeter. So yung distance nitong maliit na line na to dito sa another line, that is equal to 1 millimeter. Paano naman ang atom? 'Di ba sobrang liit na ng 1 millimeter? We are going to divide the distance between this one and this one by 10 million. So, ganun kaliit yung mga particles ng atom. Sobrang liliit nila. Basically, atoms are made up of three subatomic particles. These are protons, the neutrons, and the electrons. So now we are going to discuss the difference between the three subatomic particles. Let us explore the insides of the helium atom. For example, itong buong circle na to, yan ay yung atom. Inside the atom, meron tayong tinatawag na nucleus. The nucleus is composed of two subatomic particles. We have number 1, proton. Ito yung proton natin. Since helium ang ating pinag-uusapan, dalawa ang kanyang proton. So this is a proton. Ang kanyang charge ay positive at ang relative mass niya comparing to another proton is 1. So for example, meron kang isang proton, i-compare mo yung kanyang mass sa another proton. So magkapareho lang sila, so it is equal to 1. So yung bilang ng proton, siya ang mag-dictate kung anong magiging element siya. Now dito, dalawa ang ating protons, ibig sabihin nun, siya ay helium. Another subatomic particle inside the nucleus is the neutron. So meron tayo ditong dalawa. So this is a neutron. Coming from the word neutral, wala siyang charge. It has a relative mass of 1.001. Ibig sabihin, yung bigat ng isang neutron at bigat ng isang proton ay halos magkapareho lang. Ang tawag dito sa pinagsamang neutron at proton ay nucleon. Ibig sabihin ng nucleon, these are the particles inside the nucleus. So pag sinabi nating nucleon, this is the collective term for the proton and the neutron. Next, we have the electron. Orbiting outside the atomic nucleus is the electron. Ngayon naman, ang electron, negative ang kanyang charge. And it has a relative mass of 0.0005. Or, kailangan mo, ng rough estimate lang to, kailangan mo ng 1,837 na electron para magkaroon ng the same mass sa proton. So that means you will need 1,837 electrons in order to have a mass that is equal to a proton. Ganun kaliit ang mga electrons. Kaya yung kanilang mga mass ay negligible or kahit hindi na natin isama sa mga computations. Now, in your physics, pinag-aralan natin na same charges repel, opposite charges attract. Pero bakit dito sa ating nucleus, may mga positive particles tayo na proton, pero bakit hindi sila naghihiwalay? Why do they not repel each other? That is because the particles in the nucleus is held by the strong nuclear force given off by gluons. When we say gluons, from the term glue, siya yung nagdidikit ng mga subatomic particles natin sa loob ng nucleus. Kaya kahit na positive charges yung mga protons na nasa loob ng nucleus na nagsisiksikan, hindi sila nagre-repel. It is because of the action of the strong nuclear force given off by the gluons. Now, this is the summary. This is your atom. The atom is composed of the proton, electron, and neutron. The proton and the neutron can be found inside the nucleus. The electrons can be found outside, orbiting the nucleus. This is the summary table. The number of protons will determine the type of element that it will become. The number of proton will identify or it will define the element. Next, we have the electron, and the number of the electron will define the charge of the atom, kung magiging positive man siya or negative. Lastly, we have the neutron. Its number defines the stability. We're going to discuss this further in Module 8. So overall balance. To review, an atom is made up of three types of particles: protons, neutrons, and electrons. Mapapansin ninyo na ang charge ng proton at ang charge ng electron ay opposite. So anong ibig sabihin nun? So the nucleus has a positive charge and the electron has a negative charge, kaya ibig sabihin binabalance out nila yung charges ng bawat isa. Kaya nagiging zero charge ang mga atoms natin. We now go to atomic number. All known elements can be found in the periodic table. We have 118 elements. These elements can be identified by their atomic number, and that the atomic number is equal to the number of protons in the element. So, ibig sabihin, kung ano ang atomic number ng isang element, yun din ang bilang ng proton niya. Kasi nga, di ba, nakadepende ang properties at kung ano magiging element ang isang atom sa bilang ng proton. So, para siyang social security number ng mga tao. Para din siyang student number sa school. So, yung student number mo ay magkaiba sa student number ng iba. Kapag hinanap namin yung student number mo, ibig sabihin, ikaw lang dapat ang mag-a-appear, wala nang iba. So, it is used to identify the element from the periodic table. So, for example, an element with 6 protons has an atomic number of 6. So, hanapin natin yung 6. So, 6 dito, kasi yun yung atomic number niya, yun din ang bilang ng proton niya. So, therefore, the element with the atomic number 6 and also has 6 protons is the element carbon. Now, this is the periodic table of elements. Kung mapapansin ninyo, meron tayo mga tinatawag na symbol. So, the atomic symbol is a letter or two letters which represents an element. So, they could either be a single letter or two letters. Kapag single letter lang siya, capitalized. Kapag composed siya ng dalawang letter, the first one is capitalized, the next one, or yung pangalawa, ay small letter. Kung mapapansin ninyo, si hydrogen, since ang first letter niya ay H ang kanyang symbol. Next, paano naman si helium? Si helium kasi, hindi na niya pwedeng kunin yung H kasi nakuha na ni hydrogen. So, si helium, kukunin niya yung pangalawang letter niya, which is letter E. So, ang magiging symbol ngayon ni helium ay He. Next, lithium. Si lithium, Li. Si beryllium, Be. Bakit kaya hindi pwedeng B lang? Kasi nakuha na yung B ni boron. So, instead of having another B, kinuha yung pangalawang letter ni beryllium, kaya naging Be. And then, there are cases na kung saan iba ang kanyang symbol sa kanyang pangalan. For example, let us have sodium. So, si sodium, Na ang kanyang symbol, pero wala namang N, wala rin A sa kanyang spelling. So bakit Na? Ang pinagbasihan sa kanila ay ang kanilang Latin name. Latin name kagaya ng sodium because the Latin of sodium is natrium. Natrium. So doon nakuha yung Na. Another example, potassium. Si potassium walang K sa kanyang spelling pero K ang kanyang symbol. The reason behind that is the Latin name of potassium is kalium. Kalium. Another example, copper. The Latin name kasi ni copper ay cuprum. So, yun ang dahilan kung bakit yung mga ibang symbols ng element ay wala sa kanilang spelling. Ang kinuha kasi or ang pinagbasehan ay ang kanilang Latin name. Now you try. So, you can pause this one and then look at your periodic table and try to answer the following in order to test your understanding. Next, we go to mass number or atomic mass. Atomic mass, atomic weight, and the mass number can be interchanged for now. So the atomic mass number includes the number of protons and neutrons since they are the two largest particles in the atom. The number of electrons is negligible or kahit na hindi na natin isama kasi sobrang liit ng kanilang mass. Since they are both located in the nucleus, the mass of the atom is located in the nucleus. Concentrated ang weight ng isang atom sa nucleus. The atomic mass number is equal to the number of protons and the number of neutrons. Now let's study on how we could use the periodic table of elements to determine the numbers of the subatomic particles. Una sa lahat, ang ating symbol. It gives the name of the element. Pangalawa, the atomic number. It is the one with the lower value. 2 ang nakalagay kay helium. So that means ang atomic number niya ay 2. Yun din ang bilang ng kanyang proton. Next, the mass number or the atomic mass or atomic weight, it is equal to the number of protons plus neutron. So ano ang charge ng mga atoms sa periodic table of elements? Kasi laging binabanggit lang yung bilang ng proton. In the periodic table of elements, all of the atoms are neutral. Ibig sabihin walang charge. So that means, kung ilan ang bilang ng positive niya, yun din ang bilang ng negative para makancel yung kanilang charges. So in helium's case, dalawa ang kanyang bilang ng proton, kaya ibig sabihin dalawa rin ang kanyang bilang ng electron. Now you can pause the vid and then you can try answering this one first before we proceed. Okay, for the answers, did you answer correctly? If you did, then that's great. It means na naiintindihan mo pa yung ating lessons. Pero pag may mga mali kang mga sagot, then that's okay. Pwede nating balikan yung ating lesson by replaying the video. Now, we go to ions. There are two types of ions, a positive one and a negative one. So bago tayo pumunta doon, let us define what ions are. So pag sinabi nating ion, it is a single atom or a group of atoms which have either gained or lost electrons. Bakit hindi protons? Bakit hindi neutron? Bakit electrons lang? Kasi 'di ba, ang atom sa loob niya may nucleus. Ang nucleus, ang nasa loob niya ay proton at neutron. And they are glued together by the strong nuclear force given off by gluon. So that means hindi pwedeng mabawasan o madagdagan ang protons at neutrons in a chemical reaction kasi nasa loob sila ng nucleus. Ang pwede lang mabago sa chemical reaction ay yung charges. Kung pwede bang madagdagan ang electron or mababawasan. An atom that loses electrons has more protons than electrons. Dahil mas marami siyang protons, mas marami siyang positive kaysa sa negative. And so, we'll have a positive charge. This is called a cation. An atom that gains electrons, remember that electrons are negative, has more electrons than protons. So, mas marami siyang negative kesa sa positive. And so, we'll have a negative charge. This is called an anion. So, paano natin malalaman kung mag-gain nga ba ng electron ang isang atom or maglo-lose siya ng electron? Now, recall your knowledge in electron configuration. Ito yung 1s2, 2s2, 2p6, and onwards. and octet rule. Let us have sodium as an example. Ito yung distribution ng electron niya. Sa first main energy level, dalawa lang ang maximum. Sa second ay 8 ang maximum. Sa third naman, kapag siya ay representative element or kapag ginawa mo yung 1s2, 2s2, 2p6, kapag nag-end siya sa S or sa P, the maximum of this one is 8. Ngayon naman, ayon sa ating octet rule, kailangan natin na magkaroon ng 8 na outermost or valence electrons in order for them to become stable. So that means si sodium atom, hindi siya stable kasi hindi pa 8 ang kanyang outermost level. Hindi pa 8 ang kanyang valence electron. So ano ang mas maganda kay sodium? Magbibigay siya ng isa or kukuha siya ng 7? So, dahil mas madali na mag-give off na lang siya ng isa kaysa sa kumuha siya ng 7, ang mangyayari niyan ay aalisin itong electron na 'to. So, dahil naalis siya, nabawasan siya ng isang electron. Ano na ngayon ang valence electron or ang outermost shell ni sodium? So, that's 2, 4, 6, 8. So, nag-follow na siya sa octet rule, kaya ibig sabihin, it is now stable. Dahil 11 ang positive natin, dahil 11 ang protons, nabawasan tayo ng isang electron kasi nag-lose tayo. Positive 11, negative 10. The total charge will now be positive 1. So in writing ions, ang mangyayari niyan ay we are going to write down the symbol and then ang kanyang charge. So dapat nakalagay dito ay positive 1 pero ilagay lang natin yung positive. It is already considered as 1. So from Na to Na positive. What about magnesium? So, sa magnesium naman, dalawa ang maximum dito sa first energy level, 8 ang maximum sa second energy level, 8 din dito sa last part kapag siya ay representative element, pero dadalawa lang yung na kay magnesium. Ano ang mas madali kay magnesium? I-give up yung dalawa niya or kumuha ng 6? So, mas madali para kay magnesium na ibigay na lang yung dalawa niya na valence electron or the outermost electron. So, kapag ginive up niya itong dalawa, nag-lose siya ng dalawang electron, ito na ngayon yung magiging outermost shell niya. Ito na ngayon yung magiging valence electron niya. So, 2, 4, 6, 8, kaya it is now stable according to the octet rule. So, originally, 12 ang protons niya at 12 din ang electrons pero nag-give up tayo ng dalawa, so magiging 10 na lang. So positive 12, negative 10, the total charge will be positive 2. So write down Mg as a symbol and then isulat natin yung total charge niya as an exponent or as a superscript. So Mg positive 2. So mapapansin ninyo kung ilan yung give up nilang electron, yun din yung magiging charge nila. What about fluorine? So for fluorine, first main energy level, dalawa ang maximum. Sa second ay 8. Pero dito kasi, 2, 4, 6, 7. Kulang siya ng isa. So ano ang mas madali para kay fluorine? Kumuha ng isa or ibigay yung 7? So since mas madali na kumuha na lang ng isa kaysa sa ibigay yung 7, kukuha siya ng isang electron from another element. So 9 ang kanyang bilang ng proton according to the periodic table of elements. At since neutral ang mga elements sa periodic table of elements, dapat 9 din. Pero kumuha tayo ng isa from another element. So naging 10. So positive 9, negative 10. The total charge is negative 1. So write down the symbol and then kung ano yung kanyang total charge. Dapat negative 1, pero kapag nag-write down tayo ng negative, it is already considered as 1. Next, sulfur. So si sulfur, dalawa ang first main energy level, 8 ang second main energy level, 2, 4, 6 sa third main energy level. Dapat 8 according to the octet rule. So, ang gagawin niya ay instead of giving up 6 ng kanyang outermost electrons, kukuha na lang siya ng dalawa. So, magigain siya ng dalawang electron from another element. Kaya ngayon, magiging 8 na yung kanyang outermost main energy level. So, ang valence electron niya ay 8 in order to become stable. So, 16 ang proton, Originally, 16 din yung electron pero kumuha tayo ng dalawa from another element kaya positive 16, negative 18, the total charge is negative 2. So write down the symbol and then write down the total charge as a superscript, negative 2. Kung mapapansin ninyo dito sa periodic table of elements, dito sa first column na to, ang kanilang charges ay positive 1 kasi yun yung mababawas sa kanila na bilang ng electron. Dito naman sa pangalawa, sa 2A, ang kanilang charge ay positive 2. Dito sa pangatlo, ang charge ay positive 3. Sa pangapat, positive negative 4. Bakit? Kasi di ba 4 ang kanyang valence electron, so pwedeng mag-give up siya ng 4 or kumuha siya ng 4. Depende sa kung anong element siya nakikipag-combine. Next, dito sa column na to, negative 3. Kasi dito, 5 ang kanilang valence electron. So, kukuha sila ng tatlong electron kaya magiging negative 3. Dito naman sa column na to, negative 2. Kasi 6 ang kanilang valence electron, kukuha sila ng dalawa kaya magiging negative 2. And then, this one, 7 ang kanilang valence electron or ang outermost electron nila, kulang na lang ng isang electron kaya kukuha sila ng isa, negative 1. And then lastly, this one, these elements are said to be stable. They are noble gases. That means they usually do not react with other elements in order to form compounds. Hindi sila nagkakaroon ng chemical reaction under normal circumstances kasi 8 na ang kanilang valence electron. So there's no need for them to give up electrons or to gain electrons. Kasi 8 na yung kanilang valence electrons so they are stable. So that's it. You can now try answering our module number 7.